Hi everybody, welcome back to our YouTube channel. In today's video, I am going to solve today's Leetcode problem. Today's Leetcode problem is 39 combination sum. So let's try to understand the problem statement, and after that we will see the approach of solving this problem. So in this problem we have given distinct integer names as candidate and a integer target. Okay, so return a list of unique combination candidate where the chooses number sum to target. Okay, so basically let's try to understand this problem statement with the example. See, in this example we have given a candidate array consist of 2 3 6 7 element, and we have a target element. So basically we have to find all the subsequence such that after summing all the things we get the sum is equal to target. So we can also take any number of time in that subsequence. So suppose if I can say, take this 7, so we give the target is equal to 7, so we take that subsequence, so be here. And if I take this element two times, and after that if I take the 3 as one time, then the our subsequence become 2 2 3, and the sum of the subsequence give the target 7. Okay, so if I consider this example, then we have element 2 3 5 and the target is 8. So the subsequence are, if I take 2 4 times, then we get the sum of 8, and if I take 3 2 times and 1 times 2, we also get the sum 8. After that 5 3 also gives the sum is equal to 8. So I hope you understand the problem statement. So let's try to see the algorithm of solving this problem using the whiteboard. Okay, so if I see the constant, so the constant of this problem statement is also very small. See, the candidate length is max 30, and the candidate I is max 2000, and the target is 200, and the target is 500. So in this problem statement, if the constant is small, then it may think about the a recursive approach. So let's try to see the approach of this problem in the whiteboard. Okay, so see, in the problem statement we have given an array, and we have also given a target, and we have to form all the possible combination from this array to gives the target is equal to 7. So in this case, if I make a combination of 7, that gives the target is equal to 7, and also if I make the combination of 2 3 and 2, then this also gives the target is equal to 7. So we have to return that combination. Okay, so basically if I if I know something about the problem on subsequence, then in that cases you may learn that pick or not pick approach. So see, every element in this problem statement also has two choices. Either this element will be pick or not pick. So we this element also have two choices, and this element also have two choices. Every element has two choices. Either in the subsequence this particular element include or not include. Then in that cases you may try all possible subsequence. Okay, and after that which subsequence gives the target is equal to sum, then we have to return that subsequence. So let's see the approach of solving the problem using the recursion. So let's try to write the index of these things. So index are 0 1 2 3. So we start with take a function that takes the index is equal to 3, and also the target is equal to 7, and contains one data structure that keep track of the list till now. Okay, so see, every element has two choices. So right now we are at index 3. So index 3 has also two choices, that is either not pick this element, that is 3 index has 7 element, or pick. So if I not pick, then we have only one choices, that we move to the next index, that is 3. Sorry, next index is 2, because we start with the last index. You may also go from 0 index to n minus 1 index, or I go from n minus 1 to 0 index. So if I not pick the third index element, so we move to the second index and our target remains same because we are not going to pick anything and the data structure remains empty. So if I pick, then at which condition we are gonna pick the element. So we are able to pick that any element when the array of that index value is less than equal to whatever target value, then we are able to pick that element. So see, right now we are at 3 index, then the 3 index element has 7, that is less than equal to 7, then we are able to pick that element. So if I pick that element, then we again leave at same index, because in the problem statement it is given that we can pick that any element any number of time. So br remains at 3 index and our target is equal to 0 because we have already picked the 7. So now the target becomes 7 minus 7, that is 0. And in the vector we are going to pick the third index element. So in the vector we contain the element 7. So we have done with the index 3. So this index also has two choices. Think about that case. So not pick or pick. If I not pick the element, then we move to the next element, that is index 1, and our target remains same, and uh, our that data structure is remains empty. And if I pick that index that is 2, then first, before picking, check whether the index at 2 will be less than or equal to target or not. So in these cases, the element at 2 is 6, that is less than equal to target, then we are able to pick that element. So if I pick, so we again leave at same index, because we have in the problem statement is it is given that we are able to pick any element any number of time. Okay, so the our target will be become 7 minus 6, that is 1, because we are pick the second index element, that is 6. So the target will be 1 and the data structure contains 6 element. So till now this thing happened. Okay, so let's first try to solve this left subtree, and after that we are going to the right subtree. Okay, so this index also has two choices, that is either not pick or pick. If I not pick, then I am moved to the 0 index and the target remains same and data structure remains empty. And if I pick the index 1, then see whether pick or not. So for that cases we have to check whether array of index is less than equal to target or not. If this this is true, then we are pick. So in that cases we are at index 1, and at index 1 the element is 3, so we are going to pick that element. So we again leave at index 1 and our target will reduce to 4 and our data structure contain element 3. Okay, so we are doing these things because we are pick the element at index 3. So after that, this case also has two choices, that is either pick the 0 index or not pick. If I not pick, then move to the minus 1 index and target remains same and data structure will be empty. And if I pick that element, so be picking it only possible when the at that index the element is less. So if the element is less, yeah, it is less, so we are at 0 index, then now we, if I pick the 2, then our target will reduce to 5 and our data structure contain 2. Okay, so if I reach at minus index, then in that cases we have to return, because for minus there are no existence of minus element in the array, so we have to return from this condition. Okay, and if I check these cases, then this cases also has two only has one choices, because we have reached at 0 index, then we have two choices, that not pick the 0 index or pick the 0 index. So see, I will proceed here. See, we have 0, 5 and we have the element 2 in the data structure. So see, if I not pick the 0 index or pick the 0 index, so if I not pick the 0 index, then what happens, we reach to the minus index and target remains same and data structure also contains same. So if we have reached the minus index and the target is not equal to 0, then it means that we are not able to generate that target. So in that cases, we simply return from these things. Okay. And if I pick the 0 index, then BR remains at 0 index and our target will be reduced to 3 and our data structure contain 2 because we pick two element two times. Again, this has also two choices, not pick or pick. If I not pick, then we went to the minus index and our target is not equal to 0. In that case, we have to returns. Okay, return. And if I pick this index one again time, then we are at again at 0 index and our target will be 1 and our data structure contain 2 okay. So after that we are not able to pick this we are not able to pick these two element because now our target will be less than is equal to 2, so we are not able to pick. Then if I not able to pick, then we are simply return. So if I consider these cases, see we have at 1 4 and our data structure contain the 3, so we are at one index. So this also has two choices, that is not pick or pick. If I not pick, then we are moved to the 0 index and we the so target is remain same and the data structure contain 3. If I pick, then for picking, first we have to check whether the array element is less than the target or not. So see, we are at index 1, the index 1 contain 3, so less than target, then we gonna pick that element. So our target will be now 1 and our data structure contain 3 and 3. So this thing, okay. And after that we are reached to 0 index. So this also has two choices, that it not pick or pick. If I not pick, then we reach to minus index and also the sum is 4, that is not 0. So in that cases we simply return. And if I pick, then we again at 0 index and our target will become 2 because we pick the 0 index, that is 2. So target is reduced and we have 3 index and 2 in the data structure. And again, if I not pick and pick, if I not pick, then this went to the minus 1 and our target is 0. Target is 2 because if not pick, then in that case we have simply returned because target is not 0. Okay, if I pick, then we again at 0 index and see we are at if I pick the 0 index, then target will become 0 and our data structure contain 2 3 2 2. Okay, and after that we have also two choices, that is we have only one choices, that is not pick because at 0 index b the element content is 2 and 2 is greater than whatever the target we require. So target is 0, so we are not pick. Then we move to the minus index and target is 0 and the data structure contain 3 2 2. So whenever we reach at index less than 0 and our target will be equal to 0, then in that cases whatever the element content in that data structure, we print that data structure, or you may say that we take a 2D array in which we have a stored that data structure. So our data structure contain 3 2 2. So we have to return that things. And after that, if I proceed this section, then we also may get this 7 as a candidate of the list. So we also store it in the 2D data structure. So this and these are the two answer we get after doing this, after solving this problem. So sir, so the output will be equal to this thing. So I hope you all understand the approach of solving this problem, because I am going to show this problem statement using the recursive subtree. So this is a very interesting thing if you try to solve any recursive problem with the help of recursive tree. So I hope you all understand this problem statement. So let's try to see the code for better understanding. So whatever I do here, I will write simply code of that things. So see, first I take a global 2D vector because we have to return finally the 2D vector. So after that, see, we take the size of the candidate. So take the size. After that, also take a temp variable that is data structure that store the element till now, pick or not pick. Then again take a helper function that take the last index and target that require, and after that take this candidate array and also this temperature temp data structure to store the element. So see, whenever we, this is the base condition, whenever we reach that is less than 0, that is -1 index, and then check whether the target is 0 or not. If target is 0, then whatever it in the temp vector, we push it in the answer array, and if not, then we return, simply return. Okay, and after that when we are going to push any element in this data structure, for this we have to check whether the candidate index is less than equal to target or not. If this happens, then we are going to push the element in the target, and after that we call the function for the same index. You have to take care of that thing. After the target will be reduced to target minus candidate of index, and candidate is same as candidate and temp is same as temp. And after doing this thing, we again pop that element and again search for this thing whether we are again able to generate any possible sequence or not. So for this, see, this is peak condition and this is not peak condition. So we do these things and try all possible thing, and whenever we get the target is equal to 0, then we push it in the answer vector. So I hope you all understand this problem statement as well as the algorithm behind this problem. So let's try to submit this code. Yeah, see, I have some network issue. So if you try to submit this code, then you will get the correct result. So thank you for watching the video. See you in the next video.